The last property we want to look at is really to do with addition of functions. So two functions between a and b. So let's go with f of x plus g of x with respect to x. And we're kind of thinking about this as a single function. So like the function that we'd get when we add f of x and g of x together. Okay. Is equal to. So the principle says this. Well, if I've got two functions that I'm adding together, I'm trying to find the integral. Well, I can look at them independently. So from a to b, I can look at f of x with respect to x, and then I can find the integral with respect to a from a to b of g of x, and I can add them together. So really, it's kind of quite an important thing because without this, we don't really have any rule to try and work out a function with more than one term in it. So if there's more than one term in it, we treat them as independent of each other. We find out the integral of that, we add it to the integral of that. So that might look complicated, but it's it's not. It's kind of obvious, really. I'll show you an example. So from a to b, let's stick with a to b. Let's say like x squared plus 3x. Okay, so that's what I'm talking about. So we've got a function that actually has two terms in it. So what we do is we're actually thinking, well, from a to b, what's the integral of x squared with respect to x? And we're going to add from a to b of 3x with respect to x. Okay, you don't necessarily have to write it out this way, but this is the way you've got to think about it in terms of finding the integral of that independently, the integral of that independently, and adding the two together. So we'd go then, well, the integral of this is going to be x cubed and then 1/3 from a to b plus the integral of this. So I'm going to add a power to there, so it's going to be x squared, okay, divided by 2, so 3 on 2. So square brackets from a to b. Okay, so that's really all it's doing. Okay, sorry, I'm just going off the screen a little bit. There we go.